Hello. In this video, we're going to look at an application of the law of sines, and you're going to see how practical it is. I just want to remind you that when you're talking about law of sines and law of cosines, those formulas apply to all triangles, not just right triangles. Okay. All right, so here's this problem. It comes from the book Analytic Trigonometry with Applications, 11th edition, and you look in their law of sines. I don't remember exactly which problem it is, but you have the wing of an airplane, and notice they've got the triangle right here, so it cuts across right here. And they're saying that they want you to find this angle here, beta, and then this side C, and they give you this angle right here, 33.7 degrees, okay? And they give you these sides, 18.2 meters and 11 meters. So go ahead and find what's missing. All right, so as with most problems, the best way to do this, if you could, is go ahead and pause the video and see how far you can get, all right, and get to the answer. First place, of course, would be to go ahead and draw the triangle that represents this situation. Label everything you know, label what you don't know, and then start using your formulas. Okay, so if you can, go ahead and pause the video. I'm going to go ahead and continue. All right, so I'm going to redraw this triangle, right? And to me, it looks something like this, right? So here's beta that they're looking for. This is 33.7 degrees. This is 18, oh, sorry about that. That was 18.2 meters. Let me get that. 18, oh, that's 0.2 meters. Still can't seem to get that, can I? Hold on. It's always hard when you're on correction tape. And then 11 meters. And I guess you have some help from my cat. Okay, sorry, Bobo. Oh, I love you too. All right, so this is side C. So gamma is forming side C. Beta is forming side B. Right? And then you have, this is alpha. Oh, so sorry. Let me just check to make sure you guys can see this. Sorry, he really banged on that one. And then alpha is forming side A. Okay. So now, I can't really deal with gamma and C because I don't have either one of them, right? So if I'm going to use law of sines, I want to start with what I have. So I have here alpha forms A. I have both of those. And then I have B, but not beta. So I'm going to go for that. So I'm going to basically set this up as, and I want the angle to be on top. Remember, I can either have it's a ratio, so I can set it up how I want. So I'm going to have the angle beta on top. So I'm going to have sine of beta is what I'm looking for. Forms, I did it again, 18.2 meters as, and then here, sine 33.7 degrees forms 11. Okay? Now, and what I meant by that is I could have switched this and had the lengths on the top in the numerator and the angles on the bottom, but it's easier to do it this way, right? Have it the unknown in the numerator. All right. So at this point, I'm going to multiply both sides by 18.2. Let me just do that in another color. All right, so multiplying here. And that way I have sine of beta equal sine of 33.7 degrees times 18.2 over 11. All right, so now I can find this value and then take the inverse sine. If I really want to be super precise, if I need that kind of precision, I can just say beta is the inverse sine of all this stuff. So that's up to you, but I'm going to go ahead and tell you that all this, when you put it in your calculator, is going to be 0.91802. You want to go out at least 4 to 5 decimal places to get the accuracy that you need. All right, so there's sine beta. Now I take the inverse sine of both sides, right? And remember, that is not a multiplication. So even though here I can write on both sides, on whatever side of the equation I want, here I have to say I'm taking the inverse sine of that side, and I'm taking the inverse sine of this number. All right. All right, so now this will just give me beta is the inverse sine of 0.91802. Be sure you're in degree mode because we're dealing with degrees. So if you put this in and you're in degree mode, put that in there, you should get that beta is 66.6 degrees. Okay. Now, let's take a look, because if I look at my picture, and this is what I'm trying to find, right? This angle right here. That looks to me to be a lot more than 66.6 degrees. You're like, wait a second, that's more than 90 degrees. So what do we do? Well, let's take a look at what the theory tells us. Remember, get a clean sheet here. So remember on the unit circle, right? When I get 66.6 degrees, what am I really finding? So you're rotating out from here, some 66.6 degrees, and you're basically saying that since you found that with a sine, you're saying that the y coordinate is 0.91802, right? But what you're really looking for now is the other angle, right? Somewhere. So you reflect this over here, and you'd get a triangle like this, right? Where this y coordinate is also 0.91802, right? And you're looking for what is this angle right here, right? That's what you're looking for. All right, so what do I do? Well, I say, okay, I see that, different color, that if I were to rotate 180 degrees and then back up this amount, I would find that. But I know that this amount is also what? 66.6 degrees, right? So this value here is 100, this angle would be 180 minus the 66.6. Right. So when you do that, you go 180 minus 66.6 degrees, you will get, let's see, what did I get? 113.4 degrees. Now that makes a lot more sense. And what that's representing is here you start at 0 and you rotate out. Here's 90 and then here's 113.4 degrees. Right? So now we see on our picture that beta is 113.4 degrees. Yay! So we found that out, right? So we can actually put that also on our airplane. So now that makes more sense here. So this is 113.4 degrees. Okay. So last thing to find now, we found these, we know these two angles and these two sides. Now we need to find this angle and this side. Okay. So if we want to do that, what we can say is, well, I've already got these two angles. The sum of all three angles has to be 180. So gamma is 180 minus 33.7 minus 113.4. So let's go ahead and do that. So define gamma. Take 180 minus the 113.4 we just found minus the 33.7 that they gave us, and we'll get 32.9 degrees. Okay? All right. So now we're here where this is 32.9 degrees. And we just have to find C. So I'll set it up so that this angle forms this side, as you can pick something else like this angle forms that side, or this angle forms that side. It doesn't matter which one you pick at that point. So let me go ahead and set that up. So I'm going to say here now that C is to sine 32.9 degrees, as, say I'll take 11 is to sine 33.7. Okay. That, remember, that's coming from this picture right here. So I said, I want to know this. I know this angle. So this angle forms this side. So sine of 32.9 forms C, as, and then I picked this one. Sine of 33.7 is to 11. So now this is kind of nice because now you can just multiply both sides by sine 32.7 degrees. Right? Just some number. Sine 32.7 degrees. Right. Oh, is that right? 32.9. It looks like. Sorry. so close. Okay, and so of course these cancel out, and you're left with C equals sine 32.9 degrees times 11 over sine 33.7 degrees. And when you put all that in there, you'll get 10.8 meters. Okay? All right, so let's go ahead and just label that. It's going to be 10.8. And then on your, if I can find it again, your picture, which is a lot nicer to look at, we now know C is 10.8 meters. And we also know that this angle is 32.9 degrees. So now you know everything about the wing of that airplane. And it makes sense. We used context to let us know that we needed to find that other angle. So if you remember, we had to go through and look at the circle and see what was the other angle. And we were able to design a nice airplane wing. Thank you so much for listening.